Okay, so that's what B does. What does this A do? What does A do?
How far up and down?
Okay, another name for how far up and down is amplitude. What does B do? B changes the period. What does C do?
Is it a horizontal shift?
Not a horizontal shift,
Moves it up and down?
vertical shift. It's a vertical. So this is a vertical shift. Okay, this is just a reminder of what happened to you guys back in chapter 4. Now, looking at the sine function, just sine, guys, the number in front of theta is 1. So the period is what? What's the period of just sine? 2 pi. Okay, but what's the interval? What are you counting by? How do we get the intervals again? Divide by 4. So if you divide 2 pi by 4, you get pi over 2. So you're going to count by pi over 2, pi, 3 pi over 2, and 2 pi. So here are your 5 key points. What's this number telling you right here? The number in front of the sign is amplitude. You're going to go up 1, you're going to go down 1. That's the top of the wave, the bottom of the wave, okay? Where does sine start? Sine at 0 degrees, or 0 radians. Highest, lowest, or right on the midline? Right on the midline. Okay? By the time you get to your first interval, you're at your highest or lowest? How'd you know it's highest?
It's positive.
Positive sign, it's highest. Then back to the midline, then lowest, then back to the midline, and it's just a wave, is all it is. Okay? This is just a repeat of chapter 4. Okay, do that one. Okay, this doesn't take long. Matter of fact, I think most of these should be graphed in 30 seconds or less. Get a period of pi. All you have to do is divide by the coefficient in front of theta. What's the interval in this one?
Pi over 4.
Yeah, cut it in 4 parts, pi over 4. Okay, so you're counting by 1/4 pi, 2/4 pi, 3/4 pi, and 4/4 pi is pi. Put a 0 right here, and here we go. Where do we start? Oh, sorry. I forgot. What's the amplitude?
1.
1 up, 1 down. Here we go. Sine starts at the midline. Either goes up or down. If it's positive, it's up. Negative, it's down. We're going up. Up to the peak. By pi over 2, you're back to the midline. By 3/4 pi, you're at the bottom. And by pi, you're back to the top. Or sorry, I said that wrong. You're back to the midline. Doesn't this graph and this graph look identical? And they should, because they're both sine functions. But one graph ends at 2 pi and the other graph ends at pi. So they are different. It's just they look the same. Okay, try the next one. 3 sine of theta. Okay. Well, this is sine of theta, so the period is, go ahead and say it. Louder? 2 pi. Okay. Cut that in 4 equal parts. Divide by 4. Is that what you did? Pi over 2. Here's 2 pi. Here's pi. Here's pi over 2. Here's 3/2 pi. Wow. Why did I go up 3? Why did I go down 3? The amplitude right here. It's 3. Okay, where does this start? Where should I start?
0.
At the midline. Right at the midline. By the time I get to my first interval, I should be at the peak or the valley. In this case, where?
0.
No, at the first interval? Peak. Because it's positive. Then it'd be 0. Then it would be -3. Then it'd be back to 0. There it is. These all look the same, but they're slightly different. This one's up 3, down 3. This is up 1, down 1. They all look the same, but they're if I put them on the same scale, they would look different, but right now they all look the same. All right. What does the +2 do to this? Moves it up 2. This graph right here just goes up 2. Here's me thinking, okay, if I'm going to graph this, amplitude is 3. So there is what it would look like, except I got to raise it what? Up 2. So where is the highest part of the wave going to be?
5.
5. So right here is the highest. Where's the lowest going to be? -1. Where's the midline going to be? Yeah, here was the midline. Now it's up 2. There you go, guys. So you're between 5 and -1. We start on the midline. Oh, I forgot to ask the key question. What's the period? If this is 1, the period is what? Two pi. Yes? Interval's what? Pi over 2. There you go. So 2 pi here, pi there. Start at the midline by the first period, or sorry, the first interval, you'd be at your peak. Back to your midline. The next interval, you'd be at the bottom of the wave. And then here, back to the midline. So, just like that. Good? Okay. Hey, that's chapter 4 in a nutshell. Are you okay? This was not supposed to surprise anybody. Okay. Turn the page. And here we go. All right, let's graph this polar equation. By the way, this is not polar. Why not? It doesn't have what?
Theta or R.
It doesn't have the R. It's got theta. It just doesn't have the R. So when you graph this thing right here, you're going to graph this. R equals, and I don't remember what it said, but what? What is it up there? I can't.
3 plus 3 cosine theta.
3 cosine?
Yep.
Theta? Okay, there it is. That is what you guys are going to graph in just a little bit. Okay. But we're up here right now. So what we're going to do is we're going to take every one of these equations that are on our worksheet. First, we're going to graph them on a Cartesian plane. So basically, the XY plane. And when I say XY, it's kind of weird because X is really theta, and y, well, y is y, so nothing changes there. So here I am graphing this just like I did on the previous 4 slides. Okay, except this is cosine, not sine. So can I give you 30 seconds? Can you graph this on the Cartesian system? Theta there, y here. Oh, sorry. Guys, I gotta tell you something. Stop. What's the period? What is it? 2 pi is the period, right? Okay, don't go on. Please don't go on. I gotta tell you something. What's the interval? Divide that by 4. What do you get? Pi over 2. Okay? I have to tell you something. When you go by pi over 2, do this for me, please. Give me 3 intervals, 3 tick marks to stand for your first interval. You're counting by pi over 2, but go 1, 2, 3, pi over 2. 1, 2, 3, pi. 1, 2, 3, 3/2 pi. There. Please do that, because I'll show you why in a little bit. Okay, now I'll graph it. Amplitude was 3, up 3, down 3. But what does this little piece mean right here?
It's a vertical shift.
Yeah, vertical shifted 3 up. So the maximum 3 is not going to be 3. It's going to be what?
6.
The max is 6. The minimum, -3, is really going to be what? 0. This is the bottom of the wave. This is the top of the wave. And the midline sits where?
On 3.
On 3, yeah. So there's the midline. Okay. Now let's do cosine. Cosine at 0. What's cosine at 0 degrees? Max, it's 1. It's actually 1. Cosine at 0 is 1, but 1 times 3 is 3, and 3 plus 3 is 6. So you will be at the max. Cosine either starts at the max or it starts at the minimum. Well, it's going to start at the max because this is positive cosine. By the time you get to the first interval, you're going to be on the midline. Second interval, the bottom of the wave. Third interval, back to the midline. And the last interval, back to 6, the max. Okay. Now, can I go this way? Here. 1, 2, 3. This is negative pi over 2. Okay. Where am I at right now? On this side. Go back 1 interval. Here I'm at the max. Wouldn't they be right here at the midline? Yeah? And then if I did 1 more group of 3, 1, 2, 3, I would be back in the midline. Now, here's what I want to tell you. Please listen to this. You guys, here's the problem with what you're going to do. You're going to go like this. Okay, and you're just going to kind of wing it, and it's going to be off by a little bit here and a little bit there. And then you have to translate all these points down here. For you to be a little more precise, watch what I do. Now, if you don't want to do this, that's okay. You don't have to. But I'm trying to help you get a little more precise. So here's what I do. I jump on my midline. I'm jumping on this point. To get a little more precise, I go like this. From the midline point, I go, there's 3 tick marks. I go back 1. And because this goes up, I know it's going to go up here somewhere. How far up? Halfways. What's halfways between 3 and 6? Halfways between 3 and 6? 4.5. So here's what I do. I go back 1 tick mark, and I go up halfways. Now, when I go to the other side of this, 1 tick mark this way, I go down 1.5. Which leads me to believe this one is 1.5. You want to know that because you're going to graph these points down below. Now, after I get done with this midline point, I go to this midline point. And I go backwards 1 tick mark, down halfways. Then I go back here, and I go to the right 1 tick mark, up halfways. So now I'm at 4.5. And if you don't believe me that these are the points, then you go ahead and put some points in then if you want. Okay, here I'd probably go back a tick mark, up halfways. This helps me graph a little better. And by the way, this one I'd go back 1 tick mark up to 4.5. There it is. Okay? See, it just makes my graph look a little better. Okay? All right, here we go. Your job is to get it out of the XY coordinate system and put it in the R theta coordinate system down below. So you need to graph every one of these points down below. Okay, how do we do it? We take this point and we start to think about it. What is that point right there? What's that point?
0, 6.
Say it again.
0, 6.
0, 6. So he says 0 radians up 6. Do you guys agree? Yeah? Okay, well, guess what? You get to go graph this point down below. But here's the problem. The problem is, Christian said 0 radians, comma 6. Well, theta is second. You have to put your angle second, your radius first. It's 6, 0. So how do I graph 6, 0 on the polar graph? And guys, I know you can't see my circles. I get that. You can't see them, but how do I graph 6, 0? 6 to the right, and then rotate it how far? You don't have to rotate. So here's 6, 0 right there. There's my first point. I'm done. That's it. Go get your next point. Where's your next point? Okay? Right here. What's this point? Okay, so no one's saying anything. Okay, see this is 90, right? That's 90. You know I'm asking you for this point. What's this interval right there? If this is 90, this is what? First one is 30 degrees. This one must be 60. If you want radians, fine. Let's go pi over 6, pi over 3. I don't care what you write down or think about in your head. I don't care. I just need you to understand. You need this angle. What are we going to say here? Say again. Okay, there it is. Pi over 3, 4.5. If you want degrees, you'd say 60 degrees, comma, 4.5. Okay, down here, when you graph it, you're going to graph 4.5, comma, 60 degrees, or pi over 3, whatever you want. Okay, let's go 4.5 out. 60 is probably about right there. That's my guess. I just don't have graph paper. I can't see my graph, so I'm guessing. Okay, go get another point. My other point would be this one right here. Boy, I think that one's pretty obvious. What is it?
90.
It's 90 degrees. Pi over 2, comma what? 3. So let's go down below. Let's go 390. Okay, now, here's the deal. I didn't tell you to do something, and what I was going to tell you to do before I did this is I was going to tell you go look on page 787, because on page 787, all the pictures that you're going to get are right there. So you guys don't even know what you're looking at yet. It just looks like 3 points. But here's the deal. If you go to page 787, I got to show you something before I go any further. You are going to get graphs that look like this. Here's one graph you might get. What does that kind of look like? A heart. They call these, anything that looks like a heart, they call that a cardioid. Are you on page 787? Because they're all on that page. You might get this look right here. You might. You might get this. Here's another one that you could get. This one's called a limosome with a dimple. Got a little dimple going on there, but it never touches the pole. It doesn't touch the pole. You might get this look, and that is, let's see here. It kind of goes like this. This is what they call a limosome that doesn't have a dimple. They call this one convex. I'm just trying to show you what you're going to get. There's another limosome. It looks like this.
Please excuse this interruption for one important announcement. Girls soccer JV's game today has been postponed. Instead, varsity should meet in the gym foyer at 4 o'clock for practice, and JV will practice from 5 to 6 in the main gym.
This one's called limosome with an inner loop. So you got a little inside loop going on. That could happen. You have rose petals. Rose petals go like this. Those are fun. You'll like those. You have circles. You could get a circle out of this, just like that. There's a lot of things you could get. They're all on page 787. Okay, I just wanted to show you this. Now, let's go back and finish this one. All right, right now, where am I at? I'm at this one right here. What's this point? I know it's up 1.5. Yeah, isn't that 120? 2/3 pi. 2/3 pi or 120. Come on down. Go to 1.5. And graph it. 1.5, 120. About right here. Now guys, here's what I'm going to do right now. I'm going to show you, this is a very circular graph. Everything you do is circular. That's where I'm at right now. What about this point right here? Looks like 180, comma, how high up did I go? 0, which means you go out 0 and rotate 180. What's that going to look like? I'll go nowhere and then I'll rotate. I can't. I'm there. That's where I'm at. That's the pole. You just hit the pole. The origin, but the pole. All right, guys. Continue. Keep going. What's this point right here? Looks like about 1.5 up, about 240 degrees. So I'm going to go 1.5, 240, and I'm going to get this point right there. I'm looking at the clock. I'm thinking there's 1 or 2 minutes. I don't have much more time, but I'm going to ask you right now. Do you see something happening?
It's the heart shape.
It is the heart shape, but do you see something happening that's pretty critical here? Do you see symmetry? Hey guys, look at this point right here. You see that point being symmetrical over the x-axis? What do you think about this point right here that's up? It looks like it's up 3. Where is it going to go? It's going to go down 3. This point should be mirrored over. I mean, with that nice looking graph paper, it's easier, but you get this look, and then back to this point. What kind of drawing is this? This is a cardioid. This is a heart. All hearts will touch the pole once and bounce off. And once you do this, it's a cardioid. You have a cardioid laying sideways, a heart laying sideways. Okay? You don't have your homework yet, so don't run away yet. Or did I give it to you?
We couldn't have found that better.
There you go.
Nope.
Go.
Very proud of us.
You, Corey, and Ivy.
So we just do 1 through 8?
Yes. And here's the deal. If all you can get done is 5, then that's all you get done. That just means tomorrow you have more work though, right? So try get 8 done. Try. Do your best. If you get stuck, you get stuck. Look at page 787. All the graphs are on that page. You should get- Yeah,
R, and then,
they're all ours.
okay.
They're all gonna be basically this. All you have to do is graph it on the Cartesian one, translate it down. That's all you have to do. And 7, here. Okay. Kaylee, are you coming in tonight? Okay. Did you get anything done over the weekend on that parabolas and all that?